Okay, horizontal asymptotes are probably the most difficult of these. They're a little bit different. So I'm going to use the same values right here, or the same examples. For horizontal asymptotes, you don't want to factor them out. You want to leave it how it normally started. We're going to think of the top as p of x, and we're going to think the bottom equation as q of x. What we're looking for here is, what is the degree here, and what is the degree on bottom? Remember that your degree just comes from the exponent. So our degree on top is 1, and our degree on bottom is 2. I need to look at these numbers and figure out which one is higher. So that there are 3 different things that can happen. You can have the degree on p of x as larger than the degree on q of x. These are all going to be talking about degrees. You can have the degree of p of x be equal to the degree of q of x. And you can have the degree of p of x be smaller than the degree of q of x. Those are your 3 options. If this one is larger, there's no horizontal asymptote. Which we're just going to distinguish as not possible like that. If they are equal to each other, then it's a line that the equation comes from y equals degree on top divided by degree on bottom. No, I'm sorry, not the degree, the leading coefficient. Leading coefficient on top divided by the leading coefficient on bottom. So what I'm going to look for here is, are these the same? Is this one larger or is this one larger? On this one, the bottom is larger, which is going to follow this rule right here. This is probably the easiest one. It's an asymptote at y equals 0. So this equation can never cross the line y equals 0. That's going to be another asymptote. I'm going to look at a couple of the other examples that I did. The next example that I did was x squared minus 9 over x squared minus 4. Because these two are equal, the degree on top is 2, the degree on bottom is 2. So because these degrees are the same, I'm going to look at it and I'm going to say it's at the line, the leading coefficient of this, which is 1, divided by the leading coefficient of this, which is also 1. So we're going to have a horizontal asymptote at y equals 1 over 1 or y equals 1. I'm going to throw another example in there just because I want to be able to show you what's going on here that I didn't use before. So when I'm looking at these, they have the same degree. So it's going to be, again, y equals the leading coefficient on top, which is 4, divided by the leading coefficient on bottom, which is 2, or y equals 2. And that's going to be your horizontal asymptote on this one. We're actually going to be doing something different when there's no horizontal asymptote, and I will show you some examples of that in what we're going to do in the next video. It's not going to be today, it's going to be for a different assignment. So on these guys, you just need to remember this rule right here. If the degree on top is bigger than the degree on bottom, there's no horizontal asymptote. If the degree on top is equal to the degree on bottom, you divide your leading coefficients. If the degree on bottom is larger than the degree on top, it's just a horizontal asymptote at y equals 0.